Hey guys, this is Marcos Linas, and today we're going to dive into the OSI model through this cheat sheet I've made for you guys. For those who doesn't know what a cheat sheet is, it's basically an study accordion with various sections we're going to be studying. So first of all, I'm going to teach you how to read this, how to interact with its elements. So first of all, we need to focus on the number of the layers of this model. So we're going to have some logic and consistent when studying this topic. And of course, in another color, as you can see, we have two headers about the definition and some main features of this model. So in the center of the cheat sheet, we're going to have our two essential diagrams that are going to be very illustrative for us to be studying this. And it's going to cover some sense when we cover the topics. So we're going to start with the definition. So what is the OSI model? Well, OSI stands for Open System Interconnection, and is a standardized reference framework for conceptualizing data communications between networks. We can find this on the official standard ISO 7498, which was released in 1984. So we can review some of the main features of this model. So we can say it's a universal blueprint for understanding how devices communicate over network. It provides a big picture understanding. It basically makes easier to visualize how data travel across networks, and everything it's going to cover sense when we review each of the layers I promised you guys. So it also help us view some hardware and software harmony, how hardware and software work together. It also helps us realize future proofing technology. It helps simplify troubleshooting when coming to troubles about networking. And it also helps us comparing network functionalities when we want to make some decisions about the topic. So this model is organized in layers. We have two ways of analyzing these layers. We can start from the layer 7 through the layer 1 or the other way around. We're going to start with the layer 1, the physical layer. So the physical layer, another thing, when we study the layers, we're going to find four things in each of the sections. We're going to find the functions, the protocols, the technologies, and basically a brief definition of each one of the layers. So we're going to start again with the physical layer. This layer basically is responsible for sending bits from one computer to another. So the bits are the representation of the data in this layer. And another basic functions that this layer has is that it establishes, maintains, and deactivates the physical connection between devices. It helps us transmit raw unstructured data bits as electrical or optical signals across the network medium. And when we are talking about network medium, we are talking about cables and fibers, which is the main technology for this layer, which cables can be coaxial, twisted pair, fiber optic. We have many types of cables. It also helps us define the characteristics of the transmission signals, such as which levels of voltage we're going to be using, which pulse shapes we are going to be using when the transmission. Also help us, for example, with the rate of the transmission. Another thing is that synchronizes the communication between devices by ensuring proper timing and data encoding or decoding. And some characteristic is that devices must be connected using some of the main topologies as mesh, start, ring, and bus. And it helps us define the direction of transmission between two devices, which can be simplex, half duplex, or full duplex. It also deals with baseband and broadband transmission. So, in a summarizing way, we can say that the physical layer help us with the representation of bits, help us define the data rate, help us with the main thing of synchronization, helps us interface that defines the transmission interface between devices and transmission medium, which would be the cables. It helps us with line configuration, for example, topologies, as we said, transmission modes also. After some information was received into the physical layer, the information is going to pass. These bits are going to pass to the data link layer. The data link layer, which is the layer number 2, forms frames from the packets that are received from network layer and gives it to physical layer. This is a description when we are saying it from the first column right here. So the network gives us the packages that we are going to read in the data link layer. But when we are studying this, we can pass from the physical layer to the data link layer to the network layer. This is when we're receiving data. The other thing is when we are sending data. And the main descriptions on each of the section are basically involving the sending of the data. So it forms frames from the packets that are received from a network layer and gives it to a physical layer. What are the main functions of this layer? Well, it ensures error-free data transfer between directly connected devices on the same physical link. For example, we can use as a device an Ethernet switch, which is very important in this layer. We also say that packages data into frames with headers containing source and destination MAC addresses for identification. This is a very important function because we see what's the main unit for this layer, which is basically frames. Okay, very well. It also adds error detection codes, which are really important because when we're coding or when we're analyzing networks, an error rate is very common to happen. So having detection error codes is really important because of all the integrity checks. It also controls media access to prevent collisions while multiple devices attempt to transmit at the same time. And we have some techniques like CSMA or CD or carrier sense access with collision detection. It also flow controls the data rate to prevent overwhelming the receiving the device, which of course, for example, can saturize some devices and it leads to this device is not working. So it's really important. And to summarize, we can say it helps framing, which frames are the streams of bits received from the network layer into manageable data units. It helps us with the physical addressing, with the flow control, with the error control, and with the access control. So it's a very control point. It's a very important control point, okay? With the protocols of this link layer, we have the data link layer house router protocol, and we can find, for example, Ethernet, PPP, and frame relay. With technologies, we can have for devices, network switches, as I said, Ethernet switches. We can have bridges and MAC addresses. On the other hand, we have the network layer, which is the layer number 3, which controls the operation of the subnet. It delivers packets from source to destination across multiple links, which we are going to call networks. Between the functions this layer has is that routes data packets across interconnected networks to reach their final destination. So it basically helps delivering those data packages to the final actor of our flow of information. It performs logical addresses using IP addresses to identify devices on different networks. It also determines the best path, for example, which is the shortest, which is the least congested, for data packets to travel using routing algorithms. And I want you to focus on this function because we are basically describing a device. The device that determines the best path for information is the router. So it's going to be an important actor for this layer, the routers. It also helps us with the fragmentation, which is a process where it breaks large data packets into smaller units for efficient transmission over networks with limitations. For example, some limitations would be that it has a maximum transmission unit. So we need not to trespass that threshold, for saying like that, and it helps us maintaining over range. It also helps us with the reassembly, which helps us reassemble fragmented packets back into the original data at the destination device. When talking about protocols, we say that the main one is the network layer host router protocol, but we can say it involves also IPv4, IPv6, RIP, BGP, OSPF, and many others. With the technologies, as I said, the main device with the network layer are the routers, but we can also talk about IP addresses, subnet masks, and routing tables. Very well. So, passing to the layer number 4, we have the transport layer. This layer accepts data from the layer above, split it up into smaller units, and pass these data units to the network layer. And of course, it ensures that all the pieces arrive correctly at the other end. So between the main functions of this layer, we have that it provides reliable and ordered data transfer between applications running on different devices across the network. It also establishes sessions. We can say sessions are connections between applications. Segments data from applications into packets with headers containing source and destination port numbers for identification by specific application. So it helps us imagine that we have this big pack of data. We're going to split this data into a smaller piece of data, and this is going to have a header that contains the destination port numbers so it can reach its final actor. It also offers reliable data transfer using transmission control protocol, which is one of the main protocols when talking about this layer. It stands by TCP, and it has features like sequencing number, where it ensures packets arrive in the correct order. It also has acknowledgements, which verifies successful packet delivery and triggers retransmission if necessary. It also does a flow control, which prevents overwhelming the receiver by regulating the data flow. And apart, it offers connectionless data transfer using a user datagram protocol, which is UDP, which is the other protocol that we used in this layer. And it's for speed critical applications where order isn't crucial. For example, gaming and other activities online that are not the main things that we want to do. So, about the protocols, as I said, we have the TCP and the UDP, which evolve into the transport protocol. About the technologies, into devices, we have firewalls, and we can have also port numbers and sockets, for example. So about a summarizing of the functions of transport layer, we have that it's basically a service point addressing. It helps us with segmentation and reassembling. It has a connection control, which includes, for example, connectionless transport layer or connection-oriented transport layer. It helps us also with the flow control and with the error control. Okay, passing through a fifth layer, we have the session layer. This layer allows users on different machines to establish active communication sessions between them. Into the main functions we have it establishes, manages, synchronizes, and terminates session between applications of different devices. This is where the name comes from, because it has many things about the sessions. We also say that sessions are connections. Okay, remember that is very important. So the communication when we're talking about sessions can be done in half duplex or full duplex, and it also provides mechanisms for data exchange and error recovery during the session. It can negotiate sessions parameters such as security levels or data exchange formats, while some functionalities are provided by higher layers or the operating system. Specific session layer protocols exist for specialized applications, for example, remote procedure call. This is some description of the protocols that we have in this layer. The main one, of course, is the session protocol, but we can have, for example, the RPC for specific applications. It also has a token management, where this layer prevents two parties from attempting the semi-critical operation at the same time. Kind of what the layer that the previous layer wanted to do about the data flow, but specifically focusing on a critical operation. We also have synchronization, but this layer allows a process to add checkpoints, which are considered as a synchronization points into stream of data. So this is really important because, for example, if a system is sending a file of, I don't know, 800 pages, adding checkpoints after every 50 pages, for example, is really recommended because this ensures that 50-page unit is successfully received and acknowledged. For example, if we have a crash on number 115, there's no need to retransmit to the page number 1 because we have done many checkpoints. So this is really important about the synchronization. When talking about protocols, we have, as I said, session protocols, but we also can have SIP and PPTP. The technologies, we can also have firewalls, IDS, which is an intruder device system, and we can have, for example, name pipes, RPC. As I said, it also counts, for example, as a protocol, and this is everything for session layer, which is the layer number 5. We're going to pass with the layer number 6, which is presentation layer. This layer takes care of the syntax and semantics of the information exchange between two communicating systems. So basically, it's the language. Okay, we're going to translate. It helps us deal with data format, encryption, and compression. Without this layer, our two systems wouldn't be communicating at all. So it's really important. It ensures data is presented in a format that is understood by the receiving application, regardless the underlying network or device architecture. So it has to be really universal. Okay, it performs data conversion. For example, we have protocols of some coding, such as ASI, which is one of the most important ones, and it does this conversion if it's necessary for compatibility between two systems. It can also apply data compression techniques such as, for example, point zip or gzip to optimize network bandwidth usage. Also, the presentation layer is responsible for interoperability between encoding methods, as different computers use different encoding methods. So it's really important that we use some syntax that both systems can understand and we don't have any problem with the transmission of the data. It basically translates data between the formats the network requires and the format of the computer. With the protocols, we have the presentation protocol, but we also have other things. For example, for encoding, we have ASCII. For some of the, for example, images format, we have JPEG, GIF, SSL, TSL, for example. In technologies, talking about devices, we have PCs, computers, firewalls, and we also can talk about that decryption, algorithms, and compression techniques, as I said, zip and gzip. After this layer, we have the application layer, which is also really important because it's the one that us as users can see and can interact with. It basically manipulates data or information in various ways, which enables user or software to get access to the network. Between the functions, we have that it provides network services directly to users and applications. It defines application-specific protocols for network communication, and these protocols establish communication rules and data formats for various services. For example, for web browsing, we use HTTP, or for file transfer, we use FTP. We also use, for example, SMTP for email, which is one of the most important ones because the application layer has as a main function the mail services, where this layer provides the basis for email forwarding and storage. It also acts as the interface between user applications and the network, allowing users to access network resources and services. It also allows a user to log on to a remote host, for example. It provides access for global information about various services, and it represents a standard mechanism to access files and, well, to manage these files. So we can summarize this into it basically is a network virtual terminal. It provides directory services, and it helps with file transfer, access, and management, which we can involve in FTAM. Okay, file transfer, access, and management. About the protocols, we of course have an application protocol, but we can talk about HTTP, DNS, FTP, Telnet, etc. About the technologies, talking about devices, we can also have PCs, firewalls, and IDS. And we can talk about web browsers, email clients, file transfer applications, online games, or streaming services. So, I know this is kind of technical, but I want you to imagine, for example, the OSI model as 7-layer stack. Let's say we can imagine a sandwich, for example, where each layer adds an essential ingredient for reliable communication between devices on a network, just like each part of a sandwich contributes to the overall enjoyment. The layer 1, which is again the physical layer, we can see it as the breadth, which is the foundation, the physical connection between devices like wires or cables, and it carries the raw data bits, like the bread holds all the other ingredients, for example. Layer 2 would be, for example, slicing up the ingredients. This layer, if we remember, cuts the data into manageable chunks, we call frames, and adds labels with the MAC addresses, so they get delivered to the right device, like a neatly sliced lunch meat, we can say. The layer 3, for example, which is the network layer, helps us finding the right address. So it acts like a GPS to the network. It figures out the best path, like the fastest route to send the data frames to their destination addresses, like, I don't know, a house number, for example. The layer 4, which is the transport layer, we can say it's the reliable delivery. This layer ensures the data arrives correctly and in order, like making sure your sandwich arrives complete and nothing spills out, for example. It offers two options. It offers reliable delivery through TCP, like a careful delivery person. It double checks everything, arrives and resends anything that was missing. But it also helps us with fast delivery, which is made by the UDP protocol, like a speedy delivery service, which prioritizes speed over perfect order, suitable for things where order isn't critical. On the layer number 5, which is the session layer, we can say it helps keeping the conversation flowing. This layer manages the conversation between applications, like keeping the chat going between you and your friends enjoying the sandwich, and it sets up the connection and ensures everything runs smoothly and ends the session when you're done. The layer number 6, which is the presentation layer, we can say is the translation layer, where it translates the data if needed, ensuring both devices understand each other. Like having, for example, a translation at a dinner party where not everyone speaks the same language. It can also encrypt the data for privacy, like keeping your sandwich a secret from others. Uh, and lastly, we have layer number 7, which is the application layer, which is basically the user interface. This is the top layer where you interact with the network through applications. It's like the delicious part you actually taste. Web browsers, email clients, and games all use this layer to connect to the network and provide their services. We can see that by working together, these layers ensure that data travels reliably and securely across networks, allowing us to enjoy all the benefits of using connected devices. So it's really important for us to check this model. Also, we have on the part of above Some important concepts when talking about the OSI model. First, we have the concept of encapsulation, which is preparing and passing the data by any upper layer to the layer below it. And it means going from the application layer all the way down to the physical layer. So basically, this one, what I told you in the beginning of the video, where we go from the application layer to the physical layer, it's called encapsulation. And if we go all the way around, we are talking about decapsulation, which is decoding data while going upwards from the physical layer till application layer is called decapsulation, okay? We also need to remember the units, okay? So I've summarized the units in this little chart. Its official name would be protocol units, and we have to remember that bits are for physical layer, frames are for the data link layer, packets are for the network layer, segments are for the transport layer, and we have data on all application layer. Okay, so we need to remember the units in every layer. Also, I've made for you a little something that we can use to remember the 7 layers. If we want to remember, for example, the encapsulation, we just need to remember all people seem to need data processing. As the first layer would be the first letter would be the first letter of the layer. So A would stand for application, P would stay for presentation, S would stay for session, T would stay for transport and for network, D for data link, and P for physical. So it's a way to remember the names of the layers. All people seem to need data processing. We're talking about encapsulation. And when we are talking about encapsulation, we can say, for example, please do not throw away sausage pizza away. Yeah, I know it's kind of funny, but it's a way to remember these kinds of stuff. So that'll be all for this cheat sheet. I hope the topic is complete. And this was made by me, Marcos Linas, and I hope everything was fine. Thank you.